Today we're going to look at an example for how to calculate a confidence interval for paired data. We are going to do this example calculating a 95% confidence interval. And what we would like to see is if a weight loss plan is effective. And so to have a weight loss plan that's effective, we would expect that before weights were larger than after weights since we're trying to lose weight. Because of that, it would benefit me to calculate my differences as before minus after, because that should give me mostly positive values. Remember though that this choice is up to you. It's just easier in the long run to be able to calculate differences that are positive, and then you end up interpreting usually a positive confidence interval, which is easier. So here, if I calculate my difference, I have 150 minus 148, so difference of 2. And then for patient 2, I have 164 minus 160, so a difference of 4. Here I have 172 minus 165, so that would give me a difference of 7. Here I have 166 minus 163, or 3. Here, this patient, because their after weight is more, they have -3, so that indicates they gain weight. And remember, we do care about the direction, so we'll use that negative value. So here the difference is 4, 4. This patient also gained 2 pounds. Here we have a difference of 11, and then 2-pound weight loss. So first, to identify our population then in step 1, our population for letter A is going to be all sun-up dieters. And then the sample for letter B in step 1 is going to be the 10 sampled sun-up dieters. So then I like to define my parameters. So here it's mu sub d. This will always start with mean difference. And then we'll state the two measurements that we're taking. So it would be mean difference between before and after weights. And then the group. So this would be for sun-up dieters. And then remember that because these problems are going to be affected by the direction of subtraction, the last thing that we do is say how the differences were calculated, and we chose up here to do before minus after. So at the end I would put where you could say where difference is equal, or mu sub d equals before minus after. So then remember that in step 2 we have that gimme assumption where we have to assume that the sampling distribution of x bar sub d is the normal distribution. And then to verify that assumption we have to do what's called checking conditions. So here our conditions are met because it's stated in the problem that the weights are normally distributed. So because population is normal. And remember, there are two ways to check conditions. Either you have to have a normal population or you have to have a large sample size. We do not have a large sample size because we only have 10, so this would have to be the way that our conditions are met. Now, to make the interval, we are going to first need to calculate our statistics, which remember is x bar sub d. So to do that, I'm going to use my calculator's edit function. And then in my list, you can see here I have 2, so 2, 4, 7, 3, -3, 4, 4, -2, 11, and 2. So then I will use the function in the stat option, but this time I'm going to move over to the calc tab, and I want one variable, stats. Then I'm going to tell the calculator what list it was in, and you can see my measurements. So even though this is calculating them the same way, the notation, because the calculator doesn't know that these are differences, will be x bar, but x bar and x bar sub d, or d bar, are all calculated the same way. So here we have x bar sub d is 3.2. Then we need to find our t-star multiplier. So first we'll need our confidence level. That tells us the column. And then degrees of freedom, remember, is n-1, so that tells us the row. So So we're in the 95 column and the 9 row, so we have a multiplier of 2.26. So then we'll calculate standard error of x bar sub d in letter C, and that, remember, is s sub d, which here is 4.02, divided by the square root of n. So we have 4.02 divided by the square root of 10. So I come up with 1.27 as my standard error. Then I need margin of error in letter D. Remember, that's t star times standard error. So that's b times c. So I have 2.26 times 1.27. So I come up with a standard error times my t star, giving me a margin of error of 2.87. And then finally I put it all together. So it's x bar sub d plus or minus the margin of error. So we have x bar sub d of 3.2 plus or minus a margin of error of 2.87. So I come up with a confidence interval ranging from 0.33 to 6.07. Now, because that confidence interval does not include 0, so 0 is excluded, that indicates that there is in fact a difference between before and after weights. Because remember, for this type of data, because we're looking for a difference, if 0 is included, it indicates that potentially there's no difference. So because of that, I'm going to interpret the interval, and we're going to start with how confident we are. So here we are 95% confident between before and after weights for sun-up dieters is between 0.33 and 6.07 pounds of weight loss. So that indicates my direction. You could also put where differences were found by taking before minus after. Any way that you can use to indicate how the differences were found or what the direction of the difference is. So it's important for you to include difference calculations somehow, because it affects how you can interpret the result. So either you can indicate which was larger using a statement like this, or you could indicate how the differences were calculated, similar to what we did up here in the parameter definition.